Hi everyone. In this video, I'll just go through the setup of the software that you're going to need in order to do the MIPS programming. I mean to say assembly language programming. We're going to do in MIPS. However, there are many software online for you to do this assembly language programming in MIPS. Okay, such as QTS, QTS SPIM. Okay, this is one software which you can go and download it, and it's quite a very small software for you to download this one. Better than this, we have another software called MARS. Okay, so when you say MARS MIPS together, MARS MIPS download, if you go in Google, and yeah, something like which you can go in the first one itself. And when you go into that, you just look for something called downloads. Look for this small button here, download MOPS. Now that's the latest version. I think you don't have any new one right now at this moment. So when you download it, okay, so let's say if I click this one and you say save the jar file. Now it's a Java related file there. So once you have once you have downloaded this, you don't have to install this. Okay, you don't have to install in this because you just need a Java um, SDK installed on your computer. So once you have, I think it should be there clearly somewhere. It should be saying it that what you need, especially yeah, new release of Java or something. So you can get a new Java SDK if you installed up. So you don't need any installation for this file, and you can directly go to that folder. Okay, you can directly go into the folder and you can just run the file here. But I'll prefer you to, like, say for example, you create a folder somewhere and you copy and paste into that folder, and from that folder you run it, so that you, whenever you create any files, new files in this programming, it'll be saved in that particular folder. But remember, we don't need to install it. Once we double click, it will run. Okay, but make sure you have a Java SDK installed on your computer. However, the process of installing a Java SDK has been given here. You can have a look. Okay, so let's say for example, I have already saved it into a folder. Okay, I created a folder called Mars. You can create any folder of your choice, anywhere wherever you like, and I've just pasted this file here. So once you have this file, and if you have a SDK installed in it, you don't need to install this program. Just double click and the program run by itself. Now if the program doesn't run, that means thing about it that your Java SDK is not being installed yet. Now in this first video, what I'll do is I'll go through all the basic um, you know functionalities of this IDE. The first good thing about I told you of this one is you can create a new file here itself, you can assemble it, you can run it, all you can do it in one single environment. Whereas some of the other IDE which are there in the market, you have to write a file or program in a normal text pad or text file, and then you have to load it in order to run them. So this is quite makes the life easier, that we can make the file, we can create a file like this new, and we can start writing the program here. Before we need to write a program, make sure that you save the file. Okay, you can create multiple file, like say when I say okay, if I want to open a new file, see they open a new tab, you can switch about the tab and you can go on writing the program, but make sure you save it before you go to assemble it. So if you haven't saved the file, if you want to assemble it, it'll be deactivated, it won't run, or it mean won't allow you to assemble it. So best thing is save the file. So let's say for example, first one, I'm going to close this file. Let's only one file is there, so let's save it. And if I save it name as test, for example, okay, now it will be saving into the default folder where your actual Mars program is residing it. Okay, now so now see what happened. Once you save it, it's giving you an option of assemble. But if you don't save it, it's not going to give you an option for assemble. And if you don't assemble it, you can't run it. So it is a three-step process here, actually: saving it, assembling it, and then running it. Now before we go into this program, let's show you a little bit more about it. Like in MIPS, assembly language, they have a register, special purpose registers, all the registers which you can see on your right hand side. Okay, so all the registers have a different numbers. Just think, let's take this way. Registers are special areas where you can store datas. Okay, you can't store instruction, but you can store data. And all these registers, okay, they have a number like 0, 1, 2, 3, 4. Now all these registers have different purpose, and they are with numbers. Now it's very difficult for us to remember all the registers with numbers, and that's why what they did is like the software is helping us to we don't have to remember the numbers, but all these registers, okay, are given a name, and by dollar sign, like $0, $80, $V0, $V1. They are most of the important registers which we're going to use in the programming, and being given here by the names. Let's say, now it can't be like a really very easy name, but still it's quite easier rather than remembering the numbers. So I'll go through these registers quickly, and how we are going to use it. Okay, we're going to teach you in next following videos. But for now, what we need to remember is $0 is just a register where you can't store anything, but by default it has the value 0. So let's say, for example, if you want to multiply somewhere with a value 0, or you want to use 0 to store it somewhere. So instead of directly using the value 0, you can use $0 as a substitute for 0 value. Okay, so it's just a like register which has a 0 value. $80 is reserved by the compiler itself, so we can't use this $80, so forget about that register. $V0, $V1, they are, I'll tell you, is exactly more or less like a function register. Function register mean any action which you want to do. Let's say, for example, if you want to print, or you want to input, or you want to come out of the program. So all these actions, okay, has to be done by notifying or by storing a number in this two function register. Okay, mostly we'll be using only one V0. In some places we might be using V0 and V1. So let's say, for example, if I want to say print, so you know what we have to do is we have to load a number in V0. So the moment we load a number, particular number, they understand, oh, you want to do printing. Okay, so so what those numbers are, we'll go through those numbers in a while. But just remember that any actions or any functions that we need to do it, like printing, input, exit, has to be done with the help of V0 and V1. It's a very important register, V0 and V1. Now $A0 we'll be calling as A2, A3, all these three is called argument registers. Argument registers mean if I say, okay, I want to print something. Okay, so now the things comes up in the mind, okay, what do you want to print? So whatever we need to print, whether it's a number or whether it's a string, whether it's a float, has to be loaded in A0. Okay. Now in some cases of the programming, we might have to load in A0 as well as A1, A2, okay, A3. So in some programming, we might have to use one argument register. We might have to use two argument register, 3 argument register, 4 argument register. So it depends on the type of programming, but mostly we'll use only A0. Okay. So, but you need to remember that we have 4 argument register, A0 to A3. Now, you know, in the high level language programming, you need variables to store a number. In a similar way, if you need a storage place to store numbers, here is from T0 to T7, T0 to T7, and then you have more down T8 and T9. That means altogether T0 to T9, you have 10 temporary registers. Temporary register, just let's take it as a common register where you can store a temporary data like this. So it's just, you can say, is a substitute of variables in high level language. So in high level language, you can take any variables you feel like. So here we don't have those names, but instead we have given temporary registers from $30 to $T9. And then we have some more registers, $S0 to S7, that means 8 more registers for you to store values. But the only difference between S0 to S7 with T here is mostly it is like is kind of registers where you can store it um, on a permanent base, not fully permanent, but you can say it's a more like a permanent basis. When we'll reach you functions, I'll be going to the video about function, then I'll be explaining you about more in this one. But let's take it like this way. In right now, we can take from T0 all this T1, T2, T till T7, then S0, S1, all these register, even the S register till T9, we can use it as a temporary, as the storage area to store any numbers or anything. Okay, now we have some more registers important here, like call, high, low, okay, and stack pointer. Okay, so many things are there. So we will be going through as we're going to learn more about in depth in the programming. Okay, so just remember few things again. The most important is V0 right now. That's called the function register, by which we're going to do certain action like print, input, exit, and so on. So argument register is whenever you print, you have to load an argument that what you want to print in A0. So generally A0 to A3 will be used as argument registers, but we'll be using only A0 at this moment. And let's take T0 to T9, including S0 to S7 as a register where we can store numbers. Okay. Now some more are there here, important registers, V as high, low, okay, stack pointer. When we go into a little bit more advanced into the programming, we'll be explaining you all those things in details. Okay. Now apart from registers, they in microprocessor they have coprocessors. Okay, it's like a register, but they can meaning in this registers, like the way I said, you can store more or less anything. So in other words, you say you can store integers numbers, a kind of, you can say integers numbers. You can't store decimal numbers or float numbers. In order to store a decimal numbers or float numbers, that's why they have created a separate type of registers from F0 to F31, and they are called coprocessor, where you can store decimal numbers. Remember, it's not integers but decimal numbers. And if just letting you know that once you're storing float numbers, guys, you can store any in any registers from F0 to F31. But if you're storing double numbers, make sure you store all in even registers. Even register mean F0, F2, F4, F6, F8. Don't try to store double in odd registers, not in F1, not in F3, not in F7. Okay, so all the float can be stored any way you feel like in coprocessor, and doubles should be in all the even registers. Okay, so when we'll teach you about the float numbers, we'll teach you. So this is one thing. Now there are some settings here, you know, in editor you can go and you can change your size, color, like how you want the IDE environment to have depending on your look and feel, you can change it. Now in setting, you have, let's say for example, you know, like they say address displayed in hexadecimal. If you see on your right hand side here, see if you see this one, you know, these are the values which you can see here. Okay, now if you want these values to be displayed in decimal rather than hexadecimal, 0x meaning hexadecimal. So if you want to see in decimals, you can just say value displayed in hexadecimal. You just untick this and you can see all the numbers will be in decimals. Okay, so if you want the address in hexadecimals, now when you come to address, when we come to the data segment, when we execute, and I'll show you, there some address things will come up in hexadecimal. If you want in decimals, you can change it to decimals, but leave the address in hexadecimal. But the value which you want to do, that should be in decimal in order to make our life easier. Okay, and there are some more tools you can play around with, some more functionality you can play around with this. But let's say if you want to start with it, you can remember that we need to start with we are having two areas in the programming. One is called data and one is called text. Now all the variables need to be declared here, or the datas, you can say initial datas will be initialized here, and the actual programming will be done in this program, in this area. Okay. Now, one more thing to tell you is before we start the actual programming, if you go with where is the, yeah, these are the system calls, guys, which you need to learn by heart actually. So whenever you want to print, the system calls numbers is 1 to 4. 1 to 4 is for printing. So if you say 1, that means you're trying to tell the computer that you want to print integer. If you say 2, if you give a system call code 2, that means you want to print float. 3 is for double and 4 for a string. Now let's, for example, if you want me to just give you an example, I can show you an example. If I want to print a string, okay, the code is what? 4. Okay, and where this has to be there, guys, all these system call code has to be loaded in function register, which is V0. We're giving you that answer. It should be in V0. And whenever you want to do printing, remember, especially in printing, you have to load whatever you want to print it. The arguments has to be loaded in A0, okay, or F12, which I'll tell you. So argument has to become mostly, but it has to be in A0. Can you see this? All A0, A1, mostly is in A0, yeah. Now let's give you a very simple example. You have to learn for this first of all. Let me show you this one. And if you want to input, the code is from 5 to 8. So let's learn about input and output at this moment. So 1 to 4 code is for printing, 5 to 8 is for input. Now let's say, for example, if I say I want to print a string, the code is what? 4. So let's show you small programming here. So first thing is, if you say li, meaning load immediately, load. Now whenever you know a value, let's say a number, and you want to load in any register, the command you have to use is called li. Li mean load immediately. Okay, so we know that I want to load a value 4, okay, in $v0. Sorry, $v0 comma 4. So what you're saying is that, okay, load a value 4, which I know the number is 4, so that's why it's called immediate. Load in function register V0. And we showed you guys here that the moment you say 4, you load in V0, what you're trying, indirectly you're telling the computer to print a string. Okay, but now what string you have to want to print it? You have to load the string in argument A0. So what we need to do is, let's take a message. So you know how you declare, how you going to declare a message. So let's say a message, you give any name to the variable of a message, any name you can give it. You have to define the type, and the type should be called ASCII get. Okay, so you know how you say in high level language call string. Okay, so in other words, this is a data type. Now after that, you need to say what message you want to do. Say, let's say my message will be, this is my first program, for example. Okay, this is my first program. So once you know, once you have this message things, and if you want to tell the computer, okay, you know what, load 4 in V0. The moment you load 4 in V0, computer will understand that you are trying to tell them print a string. But now computer might say, think, oh, you know what, you want to print a string, but what string? You might be having many string. So that's why you have to load the address of this message, whichever message you want to print, in A0. So remember nicely, guys, whenever you have to print, okay, let's say for example, if you want to print a string, the address of the string has to be loaded in A0. Now you can't load the whole string in A0 because A0 is a small register where only a small number can come up. So you can't store the whole message. So normally when you want to print a message, normally what we do is we load the address of the starting string. Okay, so when we want to load the address, that's why we're going to say the word load A. Load A mean load address of the message in A0. So once you have loaded the address and you told them that you want to print 4, meaning print a string, okay, you need to give a final call as syscall. So when you give a final call syscall, what they does is they load the address of message in A0 and they print that message. So this is how the computer does it. Now let me show you how do you save it, how do you assemble it, and how do you run it. As I told you, you need to first save it, guys, by a name, and then you need to go and say run and assemble it. Once you assemble it, you see, check for any errors. Now if you have any errors, they'll tell you the line number. Okay, let me make a mistake here. Let's say for example, if I give something else, okay, which is not allowed like this, okay, it just only take only one parameters here. But let's say for example, I save it and I run it here. See, they'll give you an error, and they also point you to the error, like it's having an error on what, 5, and they said too many operand. That means too many parameters are here. So you come to line number 5 and you know, oh yeah, this is what my mistake is. Delete it and then again save it and then assemble it. Now the good thing about it, they point you to the right line number, and you can specifically go to line number and you can think about it, what mistake you're doing, and correct it. And once you correct it, this 3 button will come up, guys. This kind of thing. Now this is to run the whole program in one go. This is to run the program line by line, one by one. Now this is very useful if you want to debug. And this is to reset, to go back to the very starting point. Okay, and then you can run again. Okay, so one more thing is, if you see this small 2 arrow, up arrow, down arrow, if you want to make this window bigger, you can press this up arrow, it goes up here. You can clear the window to see this nicely, and then you can run it to see that your output comes up. This is my first program. Okay, you can again clear it, you can reset it, and you can again run it nicely. Now once it's done, you can make it smaller by pressing this, go to edit. Okay, remember, go to edit and you got this program. So if you want to go, if you press on execute, it'll show you all the programming. Okay, and line by line here again. And I was talking about which memory allocation they do it or how they address it. The data segment will show you here. Okay, so this data address is in hexadecimal. If you want to see in decimals, you can again pop up this one to see in decimals. This is what I was talking about earlier. But leave this into hexadecimal, or this is for to make our life easier, we keep in decimals. Now this is what a little bit basic understanding I gave you guys about how to use this. And now we go into small program on this to learn more on this, how to print string, how to print integers and all those things. But before we start, again you need to learn it, yes. 1 to 4 is dealing with everything about print. 5 to 8 is for when you want to input. Okay, now we're going to ignore for time being 9. Now let's come to exit. If you want to stop the program, the code is 10. So remember this at this moment, and as we go into filings and all this thing, then we'll be teaching you about 13, 14, 15, okay, and all the 16 and more on advanced programming in assembly. Okay, so that's it for this video, and in the next video we'll teach you something about how to print a string or how to input a number. So see you in next video then.